Okay, voice check. Okay, voice check. Okay. So, good morning, everyone. Welcome to BMCC IAS. I am Krishna Gupta, your faculty for Geography optional. In this chapter or in this session, we'll be looking at the heat budget of Earth. What can be the heat budget of Earth? What exactly is the heat budget of Earth? Heat budget of Earth exactly होता क्या है? What is the heat budget of Earth? Okay. One thing I would like to remind you, this is a demo lecture. Okay, the admissions are ongoing for the Geography Optional Foundation course, online and offline. Okay, so you can call on the number which is provided in the description and you can join us. This class is going live on Facebook as well as YouTube. So this will be the last class probably जो अभी demo classes जा रही है, इसके बाद में जो भी classes होगी, that will be the enrolled classes. Okay, that will be the paid classes here. Okay, moving forward, heat budget of Earth हम लोग देखेंगे that we have a sun and we have Earth here. Okay, there is certain amount of energy which is coming from the sun every second or every minute. So in this case, what we see that key amount of energy which is receiving over the outer boundary of the Earth, outer boundary of the atmosphere of Earth, जो कि हम लगभग देखेंगे 10,000 स्क्वायर किलोमीटर 10,000 किलोमीटर एल्टीट्यूड है. बट मेजरली व्हाट वी से दैट कि जो हमारा एक्सोस्फीयर वाला पार्ट है, ओके, एक्सोस्फीयर वाला पार्ट है 400 किलोमीटर एंड उनके उसके ऊपर वाले पार्ट में वी रिसीव ऑलमोस्ट अराउंड 1350 we can say watts per meter square per minute. So this is the amount of energy which is received. Now अगर इसे मैं calories में convert करूँ, so this will be around 2 calories per centimeter square per second. So this is the amount of energy which is received over the surface of Earth. Okay, so this is the amount of energy that is received over the surface of Earth. Now after this energy it is received by the Earth's atmosphere, so there are certain phenomena which is taking place, and this is exactly what we are saying that कि यहाँ पे कुछ चीजें चेंज होती है. Certain amount of energy it is entering into the surface of Earth, certain amount of energy it is getting reflected back, certain amount of energy it is refracting back, and certain amount of energy it is absorbed by the surface of Earth. So here what we see that कि यहाँ पे एक और concept आ जाता है. Okay, इसे हम पहले डिस्कस कर लेंगे. Like this is the surface of Earth and the amount of insolation which is received here, okay, this is coming in the form of short wavelength radiation. This is coming here in the form of short wavelength radiation which is insolation. अगर हम देखें इस केस में, so there will be gamma rays, alpha rays, beta rays. Okay, so these will be the visible light spectrum will be also there, and this energy it is in the form of short wavelength radiation. But after this energy is absorbed by the surface of Earth, यहाँ पे there will be energy will be absorption होगा. After the absorption आपने एक Kirchhoff's law पढ़ा होगा. Okay, you might have studied about the Kirchhoff's law and the Boltzmann law. So under this Boltzmann law, whenever a body it receives certain amount of energy, it starts to act as a black body, and जब भी इसमें कोई energy आएगी, so it will start radiating energy also. Okay, this will become a black body and it will start radiating energies in terms of like heat and light. ये दोनों चीजें होगा इस केस में. And same case happens with the surface of Earth also, that the surface of Earth it absorbs certain amount of energy and it starts to reflect back certain amount of energy. Now there is certain processes through which this energy is radiating back. So in this case what we see that whatever the amount of energy it is radiated back, this is the long wavelength radiation. This is a long wavelength radiation. In terms, we also call it as the terrestrial radiation. Okay, this is also called as terrestrial radiation, while the incoming solar radiation, we call this as a insolation. We call this as insolation. Now, in the chapter of temperature, we have seen that what can be the different factors out of which the amount of radiation which is received over the different areas of the surface of Earth, it is varying or it is changing. So वो हमने उस क्लास में हमने जो प्रीवियस क्लासेस थे उसमें अच्छे से अंडरस्टैंड कर लिया है. नाउ वी नीड टू अप्लाई दिस पर्टिकुलर टॉपिक इन दिस पर्टिकुलर क्लास हियर. इसे हमें यहाँ पे अप्लाई करने की जरूरत है. So in this case, what we will understand that let's look at this phenomena at a very, let's dive deeper here. This is Earth. This is the atmosphere of Earth. Okay, this is atmosphere of Earth here. This is the incoming solar radiation which is coming from the sun. Okay, this is the incoming solar radiation which is coming from the sun. Now, when this amount of insolation energy it is coming towards the sun, यहाँ पे क्या क्या चीजें हो सकती है? Number one, the first thing that will happen here that the Earth's atmospheric layer it is rarefied. Rarefied means there are different layers present over the outer atmosphere. Okay, this is called as the rarefication. मतलब कि different layers are present here. This is called as the rarefied atmosphere. So under this condition, what will happen? The amount of insolation which is coming here, this will be struck back by certain dust particles or different layers in this case. So धीरे धीरे क्या होता है? Certain amount of energy it starts to change its direction, and certain amount of energy because of the change of direction, because of the rarefication in this case, it gets reflected back to the atmosphere. यहाँ पे reflection back होता है atmosphere में. So this is called as the scattering of light phenomena. Okay, scattering of light phenomena आपने पहले भी study किया होगा, पहले भी समझा होगा. So in this case, what is happening here? There is scattering of light over the surface of Earth is taking place. Or scattering phenomena से, for example, what we are seeing here, a total of 100 units of energy is incoming towards the Earth's atmosphere. So out of which, because of the scattering phenomena, 6 units of energy or 6 units of insolation, it is directly getting scattered from the outer layer itself. Okay, outer layer से scattering हो जा रही है 6 units की. Now, as this insolation is again coming more into the atmosphere, we here see that there is certain amount of clouds are present. Okay, now with respect to clouds, what is happening in this case? Cloud is one of the particles. It is basically consisting of certain ice crystals. If I talk about the upper air atmosphere, the clouds which are present at around 8 kilometers or 9 kilometers from the surface of Earth, these clouds, they are having just crystals of ice. Okay, they are in the solidified form. So here what happens? This insolation, it comes here. Okay, it strikes here. Now in this case, what is happening? The ice is the change of medium. Okay, ice here we see that it is a change of medium. There is the change of medium from air or gas towards the solid. Plus the albedo of ice, it is almost 99%. Okay, 99% is the albedo. What is albedo? Albedo क्या होता है? Are you aware about the albedo phenomena? What is albedo phenomena? Albedo in this case, we will see that it is the absorption and the reflectivity. In this case, what will happen? Only 1% of the energy will be absorbed in this case, and the amount of energy which is reflected back, which is the component of albedo. Here we will see that this is the component which will be reflected back directly when the insolation is hitting this cloud. So in this case, what we see that the amount of insolation which is reflected back from the surface of this clouds, it is almost around 27 units. The amount of insolation which is reflected by the clouds, this is almost 27 units here. Okay, 27 units is directly reflected back by the clouds from this atmosphere itself. So in this case, what we are able to understand that 6 units plus 27 units, we will see that this is almost around 34 units, which is being directly reflected back from the atmosphere of Earth. Now, in this case, what will happen? Our atmosphere, it consists of various gases and dust particles also. It consists of various gases and dust particles. So what these dust particles and these gases do, they absorb certain amount of insolation here when the insolation is passing through it. So it will absorb certain amount of energy in this case. So here we see that there is certain amount of energy, it is absorbed by the atmosphere. In this case, it will be 14 units, that is 14 units will be here. So here we see that almost 14 units, it is absorbed by atmosphere. Okay, it is absorbed by atmosphere here. So in this case, what I am seeing that we have here, that is 14 units plus 27 units plus 6 units. So this will almost become here like 47 units here. Now, after this 47 units, what we will see that there is 2 units. There is 2 units which is reflecting back from the surface of Earth, like from surface of Earth, where there are certain areas where we have the presence of ice near the poles. There are certain areas where we have presence of glaciers over like Himalayan mountains, Alps, Rockies, Andes. So they consist of certain amount of ice here. Okay, ice or glacier here we can see that. So this is present over the surface of Earth. So in this case, what will happen here? The amount of insolation which is coming here, it is also getting reflected back. This is done by the glaciers and ice. Now, in this case, what we are seeing that this is actually hitting the surface of Earth here, where we have presence of glaciers and ice. In this case, what we see that almost 2 unit of energy. Okay, I am taking it here. Almost 2 unit of energy, it is reflected back directly from this part. So we can see 6 plus 14, 20 plus 27, 47 plus 2, that is almost 49 units is present here. Okay. After 49 units, what we see here that there is almost 5 unit of energy, not 5, but this we can see here. Yeah, this is 49 units that we can see here. Like this is 27 plus 14. Okay, 27 plus 14 plus 6. This is almost 47 plus 2. This is 49 units. This 49 units, it is basically we are saying that it is either over the atmosphere, like absorbed by atmosphere, or either it is reflected back to the space. Okay, either it is reflected back to the space, but this is not yet absorbed by the surface here. Now, till now, what has happened, we cannot call them as the terrestrial radiation because this phenomena has not occurred till yet, that the incoming solar radiation, it is being absorbed by the surface of Earth. This is a very important part here, that if the surface of Earth is not absorbing that particular insolation, it will not become a terrestrial radiation also. So after this, what will happen? After this, what will happen? The insolation, it will be dropping over the other areas also. Okay. So here what we see that almost 51 units that we can see, 51 units of energy, it is absorbed by the surface of Earth. So in this case, what we will see that after this 51 units is absorbed by the surface of Earth, there will be certain other phenomena, that is the radiation here, that is the insolation. It will be distributed over the surface of Earth, or it will be distributed over the surface of Earth, or it will be distributed over the complete region by 2 to 3 factors. For example, number 1, there will be radiation phenomena. So by the radiation phenomena, what we will see that it will directly hit the surface of Earth which is present above it. So this will be atmospheric heating. Now, not only radiation, but in the second case, what we will see that the transfer of energy, it will be done through other mediums also. For example, there will be conduction. Okay, so under the process of conduction, like we see that the air which is heated from the surface from below, so it rises up and it forms cloud. So this is the conduction process. So under the conduction process also, we see that the atmosphere is heated. Not only conduction, but in the third case, we also see that there is convection. Okay, there is convection process. Through this convection process also, what we see that there is certain amount of energy, it is transferred over the atmosphere. Okay, conduction, we see that it will also occur over the oceans also, because the oceans, they get heated up towards the lower part of the deeper part of the oceans by the process of conduction. In this process, the part of radiation and convection, convection will work, but conduction, here it will be direct transfer of energy from one body to another body, or one layer to another layer. It will be taking place like this. Now, in this case, what we see that overall, the radiation, which is a phenomena in this case, the radiation phenomena in this case, it will be almost around 26 or 27 units will be present here. Okay, 27 units will be present here. In the second case, what we will see that over the part of convection, there will be almost around 17 units will be present here. Okay, 17 units will be present here. So this makes up for around 44 units here. So 44, we will see that this will be 25 units. Okay, this will be 25 units, 17 units. And for the conduction part, there will be 9 units. So overall, what we see that when we combine this part here in this condition, that in this case, I am taking green color for the terrestrial radiation. So for the terrestrial radiation, now it is a long wavelength radiation. So this long wavelength radiation, it is going out of the Earth's surface again in the form of radiation, conduction, and convection. So whatever the heat which was transferred, which was absorbed by the surface of Earth, now it is getting absorbed and it is getting re-radiated back towards the atmosphere or towards the outer space again. So here we see that this is again becoming 51 units. Okay, so here also we see that it is becoming overall 51 units here. So this 51 units plus what we see that this 14 unit, which was also not absorbed by the surface of Earth. Okay, I am changing color here for the better visibility. This is 14 units which is taken up here plus this 51 units. Both of these combined for 14 plus 51, this is 65 units. So in this case, what we see that the amount of energy which is absorbed in the atmosphere, this is just 14 units. While we see that the amount of energy which is absorbed by the surface of Earth in this case, this is 51 units. And the amount of energy which is re-radiating back from the surface of Earth after it is being absorbed by either the surface of Earth or the atmosphere, this is totaling for the 65 units. So here we need to understand one part, that the amount of energy by the atmosphere, this is 14 units. The amount of energy by the surface of Earth, this is 51 units. And the terrestrial radiation part, we see that it is just the 51 units here. And the overall reflection back, the amount of energy which is getting into certain process and it is reflecting back, it is, we see that it is 65 units here. Okay, so this is 65 units. So here we see that this is the radiation, or this is the part we see that is the heat budget of Earth. This is in the simplest manner we see that this is the heat budget of Earth. And when we are seeing this heat budget over daily period, okay, this is happening on the daily basis. Like in the morning, we see that the insolation is less, and towards the 2 p.m. or 12 noon, the amount of energy it increases, and by the end of the day it decreases again. But overall we see that this is a cyclic process. So this is going on daily basis. So we see this as a part of the temporal perspective also. Okay, this is an important part which we see this as a temporal perspective. Like over the 1 year, over 10 years, over millions of years, this phenomena is taking place continuously like this only. So this is the temporal perspective which we see for the heat budget of Earth. But is this the only part? No. There is another part which we also call it as the spatial perspective. That is the phenomena which is taking place over the space. So when we look at the spatial perspective, what we find here, what is the difference that we see here? Okay, under the spatial perspective, what we see that what is happening between the latitudes, we understand this phenomena in this case. What is happening over the different latitudes, we understand this in this case. So in this part, what we see that we have equator that is at the middle part. Then this is 30 degree, this is 60 degree, and this is 90 degree, which will be a pole. Then again here we have 30 degree, then here we have 60 degree, then we have 90 degree, that will be another pole here. And this 0 degree, it will be equator. Okay, so under this thing, what we see that we have certain amount of energy which is being distributed over the different regions of Earth on the latitudinal basis also. How this happens here? Let's understand this. Now, I am looking here as a part of energy. Energy will be seen here as a part of energy units. This will be seen here as a part of the energy units, which will be almost gigajoules per year. Okay, so this is gigajoules per year. So what I am seeing here that we have certain factor here like this is -4, -3, -2, -1, 0, and this is 1, this is 2, this is 3, and this is 4 here. So we see that we have gigajoules per year which is ranging from -4 to 4. Okay, so this is something which we need to understand, and we need to be very precise while drawing this spatial perspective, that how the things are changing or how the heat budget is changing latitudinally. So in this case, what I am saying that the amount of energy which is received, the amount of energy which is received from 40 degrees of latitude in the northern hemisphere to 40 degrees of latitude in the southern hemisphere, we see that the amount of energy in this case, it is quite surplus in this case. Okay, it is quite surplus in this case. And here we see that and after this we see that when we cross the 40 degrees of latitude in the northern hemisphere and southern hemisphere, the amount of energy in this case, it starts to decline towards the bottom part. Okay, it starts to decline. So in this case, what I am saying that every energy which is present above the zero energy unit, okay, everything which is present above the zero energy unit or 40 degrees north to 40 degrees south of equator, this is receiving surplus energy or excess of energy in this case. So this is receiving here surplus or excess of energy or insolation. While what we see that from 40 degrees of latitude in the northern hemisphere to 40 degrees of latitude in the southern hemisphere, this region, it receives deficit energy, or this region it receives very low energy in this case. So what we see that this region here, this is signifying this is the energy deficit. Okay, so here we see that this is the energy deficit region. This is the energy deficit region. Now in this case, what we will see that if we come to above 40 degrees of latitude, it should be like that. It has to be a very much like contrasting thing should be there. Like as I cross 40 degrees of latitude towards the northern hemisphere or southern hemisphere, it should be very high heat. And in the contrasting part, and as I am crossing here 60 degrees, 40 degrees of latitude towards the polar region, it should be very much cold. Is it like that? Or the things are very much, we can say it changes very slowly. So in this part, what we see that the things changes quite slowly in this case. Okay, things changes quite slowly in this case. For example, this is the surface of Earth, and this is 40 degrees of latitude, this is 0 degree, and this is another 40 degrees of latitude. So in this case, what we will see that in this region there will be movement of warm air. The warm air will be present here, and it will be moving towards the polar regions. But as it reaches the part of the 40 degrees of latitude, here we see that there is intermixing of air is taking place. Okay, here the intermixing of air is taking place with the polar air, and in this case what we will see that the air is here mixed up. The air here, it is the warm air and the cold air, it is mixing up, which is actually transporting the warm air towards the polar region. And in the second case, what we will see that in the same case, the polar winds, which are quite cool in nature, as it returns back, here we see that they are also cooled up here. They are also cooled up in this process. They are cooled up in this process like this. So in this case, what we are saying that the regions, they become not very steep, or there is not a very contrasting temperatures at or beyond 40 degrees of latitude. But here the heat is balanced as it is exchanged. Here we see that this is the exchange phenomena which is going on. It is exchanged between the heat surplus and the heat deficit region. Okay, the heat here, it is exchanged between the heat deficit and the heat surplus regions of the Earth. So thus we see that the temperature of Earth, it is maintained. The overall temperature over the space, we see that it is maintained over the different latitudes and different regions also. So this is the temporal scale which we see that this is the actual phenomena which is taking place. Now the question arises that how this phenomena is taking place, that the heat is being exchanged and the heat is being balanced here, or the heat budget is balanced in this case. So in this case, what we see that the factors which are resulting into such kind of exchange of heat, here number one case, that will be the movement of winds. Movement of winds. For example, it can be the permanent winds like easterlies or westerlies. In second case, we will see that there is also movement of the ocean current. Okay, the ocean currents, they are also moving. In this case, there is an intermixing of warm ocean current and the cold ocean current. Okay, warm ocean current and the cold ocean current. In third case, what we see that there are certain phenomena like cyclones or anticyclones. Cyclones or anticyclones, they are also helping in the intermixing of heat or intermixing of the surplus heat and the deficit heat in particular regions of the world, which we see nearly towards the equator also, like 30 degrees of latitude, 60 degrees of latitude. So these are the regions where we see that the intermixing of heat is actually taking place because of the cyclonic or the anticyclonic movement. All these things will be understanding in the future lectures also in quite detailed manner, that how these phenomena are taking place. But as of now, we just need to understand that how this particular phenomena, it is resulting into the heat budget of Earth. So here we see that this is exactly resulting into the balance of heat budget of Earth. Okay, so this is the balance of heat budget of Earth, which is taking place through this process here. And this is the exact diagram where we see that the heat is being exchanged between the surplus region and the deficit region of the Earth. Now, coming back to the first part, okay, we'll just take note of this part. Okay, we can draw this diagram, then we'll move ahead. Okay, you can draw this diagram. Okay, we'll just take a note. We'll just take a note here. The heat budget of Earth, the heat budget of Earth refers to the equilibrium between incoming solar radiation, in the bracket we will write insolation, incoming solar radiation, in the bracket insolation, dash short wavelength radiation. Okay, short wavelength radiation in this case, and bracket close, and the outgoing terrestrial radiation, or bracket में long wavelength radiation, maintaining the Earth's mean annual temperature, at 15 degrees Celsius, where the Earth is neither cold, nor heated, thus maintaining the same temperature, since millions of years. Okay, then we'll move ahead. आप ये constant and ये numbers लिख लो आप. This will be important. You can write this number. Okay. Energy in this case, it is in watts, and this energy it is in calories. दोनों पता होना चाहिए. Okay, moving ahead. Now, इसके आगे थोड़ा से कुछ एक दो पॉइंट्स लिखेंगे. Okay, we can draw this diagram first, then we'll write certain points. You can draw this diagram. Okay, done. Let's write the point here. The incoming solar radiation, reaches the outer surface of Earth's atmosphere, or reaches the Earth's outer atmosphere. The incoming solar radiation reaches the Earth's outer atmosphere. Point number one. Point number one. While entering the atmosphere, the atmosphere is rarefied. The atmosphere is rarefied. In the bracket we will write, it consists of different layers. Bracket close, which results in the scattering phenomena. And the 6 units of energy, is scattered back to the outer space. And the 6 units of energy, it is scattered back to the outer space. Okay, in the starting we can write, consider 100 units of incoming solar radiation. Okay, consider 100 units of incoming solar radiation. Then we can continue those part. Now, next point. As this insolation hits the clouds, comma, here the upper air atmosphere clouds, are whitish and very high albedo, and because of which, okay, bracket में लिखना in the solid form also in the solid ice form or solid ice crystals, bracket close. The 27 units of the total insolation, is reflected back to the outer space, by these clouds. Okay, next point लिखेंगे. As the insolation moves or propagates forward, 14 units of energy is absorbed by the Earth's atmosphere. 14 units of energy is absorbed by the Earth's atmosphere. Okay, so here basically we will see that in the bracket, the gases and dust particles absorb this energy. The gases and dust particles absorbs this energy, bracket close. Okay, next point. As the insolation propagates further, as the insolation propagates further, 2 units of energy, 2 units of energy is reflected back from the surface of Earth. 2 units of energy is reflected back from the surface of Earth. Okay, in the bracket we will write ice sheet and glaciers. Ice sheet, glaciers and sea ice. Ice sheet, glaciers and sea ice due to high albedo. Ice sheet, glaciers and sea ice due to high albedo. Okay, नेक्स्ट पॉइंट में लिखेंगे here we can see that the total amount of energy which is either scattered or reflected back to space, the total amount of energy which is either scattered or reflected back to the space is 35 units. Is 35 units. Okay, we are adding up here 6 units plus 27 units plus this 2 units here. So this is totaling to 35 units, and 14 units is absorbed by atmosphere, and 14 units is absorbed by atmosphere, but till now the energy is not hitting the surface of Earth. But till now the insolation energy is not hitting the surface of Earth. Now in the next point we'll write, it is 51 units. It is 51 units of insolation. It is 51 units of insolation which is absorbed by the surface of Earth. It is 51 units of insolation which is absorbed by the surface of Earth, and these 51 units is either reflected back to outer space, and this 51 unit is reflected back to outer space, number 1, in the form of radiation, that is 25 units. In the form of radiation, that is 25 units. In the form of conduction, that is 9 units. And in the form of convection, that is 17 units. In the form of convection, that is 17 units, which is making a total of 51 units, which is making a total of 51 units, which is the terrestrial radiation of Earth, which is making a total of 51 units, which is the terrestrial radiation of Earth. Okay, full stop. Next point में लिखेंगे. Here we can see that the total energy or the total insolation reflected by the Earth's atmosphere and surface the total amount of energy which is reflected or scattered by the Earth's atmosphere and surface is 65 units. Is 65 units, while while we can see here that next line में लिखना है, while we can see here that the total energy which is received by the Earth in the form of insolation, the total energy which is received by the surface of Earth or Earth in the form of insolation, it is equal to the total amount of energy scattered or reflected or terrestrial radiation thus the heat budget of Earth is balanced. The heat budget of Earth is balanced. Okay, we'll move forward. Second is spatial perspective. Draw this diagram. Spatial perspective. Never forget to mention this gigajoules per year. This is the energy units per year which we are counting it in this particular diagram. So this has to be mentioned like this only. Okay, we'll write down. It is seen that the amount of insolation received at different latitudes of Earth, the amount of energy received at different latitudes of Earth has a variation that is the 40° north and 40° south latitude, that is from 40° north to 40° south latitude, the energy received is surplus. The energy received is surplus. While from 40 degrees to 90 degrees north, from 40 degrees to 90 degrees north and 40 degrees to 90 degrees south of latitude, while 40 degrees to 90 degrees south of latitude receives a deficit energy or receives a deficit insolation, or deficit energy. Okay, in the bracket we will write, because of the change in obliquity of the Earth's surface. Because of the change in obliquity of the Earth's surface. Bracket close. Okay, in the next point. Thus we see that the spatial scale, or in the spatial scale, spatial scale, SPATIAL, spatial scale, the amount of energy received or amount of insolation received is different at different latitudes, comma, yet, yet, comma, yet, through the exchange of heat, through the exchange of heat between the heat surplus region, and heat deficit region, the exchange of heat between the heat surplus region and heat deficit region, the energy is transferred between these two regions. The energy is transferred between these two regions, which helps in maintaining the balance, of heat, at different latitudes of Earth, making Earth a habitable planet. Else it would be like, आप हीट सरप्लस रीजन में जा रहे हो, यहाँ पे 70-80 डिग्री सेल्सियस है, आप हीट डेफिसिट रीजन में जा रहे हो, यहाँ पे -40 -50 डिग्री सेल्सियस है. सो इन दिस केस अर्थ जो है, जो मैक्सिमम एरिया होगा, दैट वुड नॉट बी हैबिटेबल इन दिस केस. So thus, because of the balance of the heat budget of Earth, the Earth has become habitable because of the exchange of heat. Overall जो temperature है Earth का, this is varying between 0 to 15 degree और 0 to 27, and overall हम देखेंगे कि average 15 degree Celsius हो पाता है. Okay, now the balance of the heat budget of Earth. Okay, ये point लिखेंगे. Balance of the heat budget of Earth. Draw this diagram and write this point. The balance of the heat budget of Earth. Okay, in the contemporary time, what we are seeing that because of the increase in the greenhouse gases like carbon dioxide, like methane, so like nitrogen and various of its oxides, the amount of energy, the stay time of the energy over the Earth's atmosphere, it is increasing. So because of the stay time is increased, the amount of energy between that particular time, it has increased. So this particular phenomena, we see this as a part of the global warming. So global warming, what exactly it is? It is the increase in the amount of energy. It is increase in the amount of, or increase in the stay time. It is the increase in the stay time of the amount of energy, present over the Earth's atmosphere. Due to the greenhouse gases like carbon dioxide, methane, water vapor, halides मतलब कि chlorine, bromine. Okay, so these are certain halides. Iodine, so these are certain halides, etc., causing global warming of Earth. ओके, टेक अ क्वेश्चन, एक क्वेश्चन आप लोग लिखिए। व्हाट इज heat budget of earth, comma, how heat balance is achieved by earth. Okay, we are taking this as a simple question. We'll take this as a simple question. Why? Because abhi you are not very much apt to the uh, writing answers for the optional part. Okay, so guys, this is one of the part we see that कि ये question हम लोग फिर discuss करेंगे in the next class. Okay, try to give your responses. अब आपके answers मुझे भेज सकते हो. First thing. Second thing, this is our last demo class. So in case of further lectures, you can enroll in our program. Okay, that is Geography Optional Foundation. जो नंबर है आप उस पर कॉल कर सकते हैं जो डिस्क्रिप्शन में दिया हुआ है, एंड वी कैन टॉक ओवर दैट हाउ विल बी अप्रोचिंग ऑप्शन. गाइस, ऑल द बेस्ट, टेक केयर एंड सी यू इन द नेक्स्ट सेशंस.